Hello, CT Roan doing the buoyancy lab for this week. I think it's lab 6. I've already got my 150 milliliters of water in my beaker. I did that kind of as prep to save a little time in the video. Use the graduated cylinder. So we're gonna go with the yellow. It'll be a little easier to see, I think. We've got our ball and the boat that we made from the same half stick. So we're gonna go ahead and get it in and observe the water displacement and the buoyancy of this ball to see if it floats at all. There's a big old nope. It displaced the water by about 10 milliliters. So the ball is more dense than the water that it's in, which is why it's displacing the water and which is why it won't float. Just set that off on the paper towel there. Now we're gonna put the boat in and we're gonna see if we can get it to float. And the idea behind this is even though it is of the same mass as the ball was and the ball didn't float, that by creating empty space in the mass, it can become more buoyant, which is the same way that even though like normal boats or jet skis or whatever are heavier than the amount of water that they take up or displace, they can still float because they're hollow. Just like that. Ta-da! Keep going. Okay. And we're gonna take these 15 washers and we're gonna see how many we can add before our boat sinks, like the Titanic, except it's not an iceberg. Too soon? All right. So this is still just the normal purified water. It's not salt water or anything. Now it looks like it's already pretty close to the top of the boat, so I don't feel like I'm gonna be able to get very many in here, but there's 1, 2, 3, 4. Oh, we're getting close. 5, 6, 7. Up. Dang. Okay, so it can float with a maximum of 6, and then it sank with 7. I'm sure if we were able to work this boat out a little bit more, maybe make the walls taller on it, displace a little more of that empty space, that we would be able to get more in there, but I'm not going to take the time to do that. We'd be sitting here working hard clay all night and nobody wants to see that. All right, that was 6. So now we're going to add our salt. Handy dandy popsicle stick. Go on, you. Ignore my dogs in the background.
You're gonna have to clean that later.
That's what trash cans are for. 2, 3, 4, and 5. So my guess from this is because we're essentially adding density to what is now a solution, that the boat and the ball should float more easily. Like in layman's terms, if the weight of the water was 1 and the weight of the ball was 2, then you're adding the salt, so you're increasing the weight of the water to eventually, once you add enough salt, a point where it's going to have more mass than your boat or your ball, and they should be able to float. And that's the same way that it works with boxes or crates or barrels or whatever else you might see floating down the river. Yield. I don't know where I was going with that. You know what I'm getting at, though. Okay. That Everything's nice and dissolved. Okay, so we're just going to do that with the boat again and see if we can get more than 6.
And the ball, or?
Just the boat. I'm going to grab the original 6 that I had. 3, 4, 5, 6. See if anything changes or if it was enough salt to make a difference.
You should have did one at a time.
Yeah, gotta stay consistent. Let's dry this off a little bit as well. Don't want any excess water in there.
Is that Mia?
I think it was the dog's stomach. Okay. 1, 2, 3, 4, 5, 6. Still just 6. So my guess is that it wasn't enough salt. Teaspoons are very, very small. Wasn't enough salt to add enough mass to the water to be able to just place more weight in the boat. We could redo it with 5 tablespoons. I'm sure it would make a huge difference. It's going to be a much larger quantity of salt. But that kind of replicates how you see things moving across the ocean as well, because you know that's not fresh water, it's salt water. So the water in the ocean is more dense than the water in the pond. And that's how boats and buoyancy work.